Very good morning to everyone. So, as you know, today we have Dr. Anand Ray, and so let me first welcome him on stage, please, sir, please, and request Dr. Surabhi to hand over a bouquet to him as we welcome him. Yeah. Yeah. So please be seated. And let me request Dr. Alok Kumar to introduce the speaker for that.
Okay, so today we have somebody who probably doesn't need introduction. I'm sure all of you know him, but still protocol says that we have to have a good introduction. We all know him lovingly as the Moon Man of India. And obviously he's a very, very distinguished space scientist. He has been working at ISRO from 1982. Since then, he has been part of some of the very key leadership roles, including being Space Operations Manager for various satellite missions, including IRS-1A, INSAT-2A, and INSAT-2B. Dr. Anadurai served as Mission Director for critical INSAT and GSAT missions. And obviously you would have heard of all these satellites in terms of how important they were for the nation. And they still are. And he was the Mission Director for INSAT-2C, INSAT-3B, and GSAT-1. From 2004 to 2009, he was the project director for Chandrayaan-1, which you all know that's the mission that changed India's trajectory in space in many ways. That was a landmark mission, and later on, he also led Chandrayaan-2 from 2008 to 2013. His leadership in these landmark missions positioned India as a major player in space exploration. And later on, he became a program director for IRS and SSS, the small science and student satellites. From 2015 to 2018, he was the director at the UR Rao Space Satellite Center, which is here in Bangalore, ISRO's Center for Satellite Development. And he oversaw development of more than 30 satellites during this time. In recognition for his contributions, he was awarded Padma Shri in 2016. And currently, Dr. Annadurai serves as the Vice President of the Tamil Nadu State Council for Science and Technology and Chairman of the Board of Governors for the National Research and Design Forum. He's obviously been an extremely important figure in Indian space science, and we all look forward to hearing from him. So over to you, sir.
Good morning to all. I think I understand you had a 6-month-long course, and the last 2 days also you have the couple of lectures. And looking at that and looking at your background, I thought how I can bring in a bigger picture of the space program is concerned. Today, tell that instead of telling a story, slightly different way I'm trying to put it back. Wherein the constraints leading to innovations. Okay, we talk about innovation, but innovation is basically driven by the constraints. This is what I feel, and how it has happened in India's moon, Mars, solar missions, and beyond. Okay, and because the story is not stopping there, story is going to continue. How it is there. So I was trying to put it in a slightly different perspective, something like storytelling. Okay, but storytelling needs a character, and the character is nothing but me. Okay, so that when I'm putting it there, as like I told, 1982 to November 1982, because 1982 was a very, very, very important year for me, beyond my year of birth. Okay, so why it is happening is that is the time I graduated, and going around various nook and corners, running around rather, not even going around, and as an enthusiastic graduate. Okay, with a lot of dreams, something you can do, all these things. I graduated from ECE. At that time, ECE is like computer science. It is one of the looking forward department. Of course, even now also, a good number of people are there. But notwithstanding that, my running around was so fussy, and finally, it made me like this. Okay, I became a confused youth. Okay, so all my dreams looking like getting shattered, and it looks something beyond my scope, and the environment is not as you think about, and there is an ecosystem not as you expected. So it's a really it became like this, and this is how I appeared for the interview to ISRO with all the beards, things like that. That means 1980 November I joined ISRO, but again ISRO also this time it was like this. Okay, you look at the 80s, it was very humble beginning, and the way in which ISRO satellite center in Binya looking, things like that were like that. Okay, and the Pallakad satellite we taken in 1981. So this is a scenario. So again, the big question mark, where I am leading to, what is happening. Okay, this is the perplex environment. But again, looking back, my schooling also was something similar. Okay, makeshift arrangement of a cow shed was my schooling started. So that constraint didn't stop me to come up to this level. So then why these constraints around us should constrain us? I think is it possible to something do better than what you are expecting. I think that is the way. Then 2 weeks into joining ISRO, I gave a proposal. I cannot tell a proposal, it's a suggestive note. Okay, this is not what I expected. Instead of telling like that, what probably can be done. I think that's what a suggestion note, because that is the time the satellites were made elsewhere and being launched, and we are only operating the satellites as per the operation manuals given. And this is not the dream I was looking for. Okay, so then what can be connected? Then I was telling, once we may make satellites, but before we are making, is it possible to have in a software form to release the satellites? Of course, it's not graphics, it's beyond that mathematical forms, bringing there thermal, telemetry, power, all the system, including flight dynamics, and trying to simulate and try to realize it. Just a suggested note given, and that was given to then Director of Satellite Center, Professor E.R. Rao, and name only E.R. Rao Satellite Center has come now. So then he told, good, do it yourself. Okay, whatever you're telling is good, but is it possible for you to do that? I think that is what given. That means then it was given a jerk for me. I think this is a place where somebody is ready to appreciate what you are suggesting, and they're ready to give a responsibility to you also. And that I think I took it, but it took nearly 4 years for systematic work to understand, to learn more than what you have in your college you have studied. The system knowledge of software satellite simulator, and that in the process I changed a person like this. Okay, and no longer the beard, so something systematically has come, and now that is the satellite simulator. Whatever we have done, first ever time IRS 1A time, meant for IRS 1A, that will simulate as if it is the satellite for the control center. I think that is the one. Even today, I think we are using it for very methods. Today we are talking about India making the satellites with the fraction of the money what elsewhere they have done. One of the reason being the satellite simulators. Okay, we used to simulate, we iterate so many things, and so that we make only one hardware. We will not make multiple hardware. Okay, whatever you're supposed to do, you try to do it, model it with this. I think the one thing. Another thing is after putting the satellite also, when you are trying to understand some issues, why whatever has happened there, again you try to iterate this and to understand what is the reason for the satellite misbehaving, and again even any operational procedure we will try to do. So many things we are trying to use this. So that's how this has happened there. So then a day has come, we are already making the satellites also, and then I was in the transition road where I given option of continuing with the software development for the satellites or going the satellite operations. I think yesterday would have heard about V.V. Srinivasan's lectures, and that I think basically now our own satellites are making, and that's how I became operation manager. The option was given, yes, I took it there and moved forward. So that, of course, when you make the satellite and launch it, you expect everything go normal, but it will not happen. Because even our own mother, when give birth to us, we expect a healthy baby. But the healthy baby also, it gets a sneezing, cough, other thing. She has to look after that. Correct. Now, but that is in front of you, the baby is okay. But now this baby is, your babies are all hundreds of thousands of kilometers away. And there something happened to the satellite, you should have the mechanism to understand that. Okay, this is where that satellite simulator, what I worked, helped me to to make that puzzles and make it neatly to understand what is the problem and try to solve it. And actually that is the time frame wherein nominally satellites of this difficulty happened. Elsewhere people used to abandon the satellite. Okay, but this is the time frame where India was trying to do other way. So many of the satellites after launch had its own issues, but we understood the issues and circumvent the problems, and we used to manage the missions very, very big way. For example, one situation is INSAT 2E. The first ever time India made a very, very a big satellite which can cover overall the TV broadcasting point of view all the way from Europe to Australia. Nearly 47, 50 countries it can cover. And it was a very, very ambitious project. 10 of the such transponders were hired by Intelsat, and it was given to others. And that is the time our own India, we used to get the TTH, cable TV started coming. And when this satellite lost its two sensors in the first year of its operation, but it is basically destined to have its fuel other thing for 13 years. But first year when it happened, then the Intelsat asked us an additional one more satellite because they hired and they separated to the people to then. But then somehow we came out, Dr. Surangan was the chairman, then he basically consulted us. I told, so with this same problem, I am confident we can make this satellite to make it alive. And believe me, that satellite lived another 13 years without any problem, earning one of the highest foreign exchange on that day. $10 million in 90s is a good amount, I think we are learning. So like that, many issues elsewhere people used to abandon. I think we could do it and come back. So in the process, I have become the satellite problem solver also. Actually, outside is known like that. So in the process, when I think slowly, we are trying to operationalize many satellites, 80s, 90s, something like that started happening. And moving ahead to satellite manufacturing to meet national demands in a big way, I think India was trying to do. Policymakers also recognized ISRO can do, and many things were given the responsibility. So a good budget started coming, and we are supposed to make more and more the satellites in different fields: remote sensing, communication, navigation, science, other missions. Many things we are supposed to do that, but we got into an issue. Okay, the same time frame, the IT was keep booming, and ISRO was trying to difficult to retain the people within the organization, and ISRO was trying to difficult to inspire the people to recruit the more talented people from outside. So this was the sanctuary there. So at this time frame, this is a constraint. Again, I'm trying to put a constraint, how it being innovation. Okay, now that means you are given more and more budget started coming, and you are expected to deliver more satellite and launch vehicle, but you are struggling to retain the people within the organization, and new recruits also you are struggling to get it. What to do that? And there came an idea of innovation. I think, is it possible to inspire the people with the new mission? And that's how the first ever time ISRO talked about the possibility of ISRO putting a mission to the moon. Okay, if it all goes well, it could be reality in 2008. Like that, in a technology oration, then Chairman ISRO put forward that. So that is at this point of time, as an individual, I was given a chance. Okay, I was also one of the individual being pulled by the private industry. Okay, and private sector was pulling, and already I told here good number of other satellites I more or less stabilized, and it's a comfort zone, very comfort zone. And but now Chandrayaan-1 satellite has come. That satellite ISRO is offering to be, can you take it as a project director? I think this is the real juncture, what to do. Okay, one is you can continue with the comfort zone. Another one is you can jump to the, say Bangalore, you can jump to the private industry, which will give much more multiplied numbers with respect to salary, other things point of view. Other one is the same salary, but you're not a comfort zone, but you have to struggle for mission to the moon. Okay, new mission, and this is which one to take. I think that juncture has happened there. But we're looking at here, whether take it or not. Now you're looking at the things in 60, 50, 60, 70s, a good number of missions have gone to the moon elsewhere. Okay, elsewhere USSR and USA, things like that. But in 80s and 90s, almost zero. Okay, at this time frame, you are planning to go to the moon. Is it a correct option? Okay, because you are giving a responsibility. That is the responsibility really a responsibility, or you are being thrown to a dustbin? like that, so thinking will come. Okay, that's what is happening there. So then you look at here, even if some reason you want to go to there, uh, uh, what are the resources they have to go to the moon, and what resources you have to go to the moon. You look at here, that has nearly more than 10 times more powerful Saturn launch vehicle, which is taken to the US to the moon. But whereas ours is a very, very small, very, very humble system there, very modest system there. Typically look at here, this can take our given orbit, same orbit you talk about, it can take 140 metric tons, Saturn. We cannot take more than 4 metric tons. Okay, this is the size big imbalance sitting there. With that constraint, is it possible? Even if people have not gone for 30 years, even if you go there, what resources you have, with this, whether you can go. Like that, a lot of thinking has gone there. So, but now you look at there, how they have gone, is basically, they have the muscle power, enables them to go one shot to go to the moon. Okay, but now, with our mission, technically it is not possible to go, but what is the other way you can go? Okay, so another way going is, basically this is what I told, how the constraint gives rise to innovation. Okay, and this basically, this our PSLV, to put the satellite, a meaningful satellite around the moon, it cannot take more than 22,000 kilometers. That means near 200 kilometers by 22,000 kilometers only orbit can go. From this, you have to go 384,000 kilometers. A moon which is going around the Earth nearly 1 kilometer per second. 1 kilometer per second is going. That means from here to go over there, how you can play around. I think a lot of iterations, a lot of simulations, many things we have done, such that we are trying to use an effect of the gravity pull. It comes here, and here you try to increase. It theoretically, it gives a efficient way of using that incremental velocity there, and that will be able to increase the velocity gradually, and finally you are able to go to the moon. But while doing it, you will have enough time to calibrate many systems, like your calibration of star sensor, calibration of gyros, calibration of thrusters, your timing, many things you can calibrate also, such that your first attempt you can reach the moon better way. So this is the another way it came. That means its innovation came out because of the constraint of you cannot launch more than that weight. So, but again, yes, people have not gone for 30 years, people, and you don't have that vehicle, you can also manage. But even after going over there, what you are going to do that? Okay, the same moon, has given answer, they landed so many places, and they brought back the sample, and the landed people also told no water on the moon. Samples what brought back here also in the experiments in the laboratory told the moon is barren. So, but now looking at there, and again, this gives another constraint. In spite of all these things, if you go also, probably you will get the same answer. So then for that, why to go? That problem is there. But now looking at that innovative and opportunistic window, the innovation always gives an opportunistic window that you can look for. Say, look at here, this English giving a window for me. Okay, they landed and searched for water. Okay, I think, are you able to understand what I'm telling you the window? They landed and searched for water. You want slightly change this, search for water and land. English remains same, but slightly you reconfigure it. It gives a slightly better picture. That probably will give you an answer better than what, because the same moon will give you a better answer if you rephrase the word. It's another way I'm trying to put it there. So this is how, if you go there, possibly, that means the whole moon you see before you land. Then probably that can go. I think that's what we try to do for the Chandrayaan 1. So, but you want to do that, original project report, whatever I given to Government of India, will not enable us to do all these things. Okay, that means you have to do something better than what is existing. Keeping the same budget, keeping the same schedule. That is another constraint. Again, that constraint gives an innovation. That innovation is nothing but you try to give an opportunity. 30 years people have not gone to the moon, but now you look for an opportunity window, opportunity possibility. 30 years, some of the people are waiting to go to the moon. Is it possible for us to give an opportunity for them to go to the moon along with us? Okay, you go to the moon with the budget, with the schedule, with the PSLV. You give an opportunity who can come and join with us who can supplement and complement our objective of looking for the whole moon in a slightly different way. I think that way we opened up the innovative approach, asking for the other laboratories outside ISRO to come and join for us. And we got good number of offers outside India. Unfortunately, nothing much has come from within India at that point of time. Today, most of the things are coming. But now, with that putting together, we got from NASA, ESA, so many places. And that's how today, even today, my friendship continues with very many laboratories because of that. And they asked for the opportunity to go sit here. And this is also a big story. Originally, we thought only one instrument from outside the board. But afterwards, I landed up taking 6 instruments. Okay, because of the 2 instruments coming from NASA was very, very attractive. But it's very difficult for me. We are supposed to take only instrument, but 2 instruments are coming. The 2 instruments, even if you take, both are taking from NASA, may not be prudent for me. So that way, we opened up in a slightly bigger way, such that we took it from Europe, European Space Agency, JAXA, ESA, and NASA, like that. Some 6 instruments started coming, and that we configured the satellite like this. On paper, we're yet to go for the metal cutting. But this was presented in an International Lunar Conference. That time, then President Dr. Kalam, he told everything is okay, but now he feels something is missing in this mission. What is that missing is, he felt we are going all the way to the moon at 100 kilometer falling short. Around the 100 kilometer around the moon, you are keep going around, but that 100 kilometer gap, somehow you are making it. Is it possible to fill that gap? Such that with that, our tricolor flag has to make its own presence in the even Chandrayaan-1 itself. This is the thing he has given, another constraint. Okay, but this again told is constraint, just give a window for opportunity window for do it. How to do it? Okay, but it is a real juncture, because it's not only me, with the whole team I have to convince them. The original mission is a very, very modest mission. But we have taken updated mission with the other science instrument from other countries. Mission has become bulky. But if the PSL will do it, you have to struggle, anyhow, that point. But now Kalam is telling you go and land on the moon, first aim itself. This and this cannot go together. Okay, so then the team is telling either you take this or you take this. We cannot have this. Or else let us go back, fall back to the original mission. Within the schedule to do it, everything is there. But now that means the constraints are compounded, but compounded constraint giving a better innovation also. That means a updated mission will give a very possibly an unambiguous answer of presence of water on the moon or not. But whereas Dr. Kalam's thing is, will give definitely we can enthusiast the whole, not only within ISRO, probably that will help when we land on the moon along with the tricolor flag. That will definitely will inspire the whole of Indian community. But one of them only we can take what to do. But now afterwards we thought, why can't we take both also? A and B if we take success. But that is not as easy as I thought about, but it calls for a lot of iteration. Lot of iteration of the satellite design configuration in so many ways. Okay, on paper, I think we spent nearly 3 years. I think Alok and the team you look at here probably will be able to tell. So the satellite originally was very, very modest. Afterwards, it went through a lot of iteration, in a very big way how the resources for various instruments can be shown, and a very, very unconventional way of non-textbook satellite. Okay, previously 16 thrusters will be there for the satellite control point of view. We made it 8, not like a number by its own thing. Number of sensors reduced, and very many things we optimized, keeping the same schedule, keeping the budget same, keeping PSLV remains same, everything remains same, but by iteration alone, we could come out with a satellite configuration. Believe this satellites on paper, the design itself got 2 international awards. Okay, that's what it's happened there. Because people thought the design wise it's okay, whether it's going to make it or not, many people question, because it will have a lot of implications. We have so many instruments compounded there. Small satellite, this probably EMC issues, many issues can come. So the possibility of making this mission was big question mark was there. Though the design per se, it's okay like that. But I think we made this mission in a very, very deep way, such that complying all the requirements of any satellite which goes to the moon are supposed to be there. And that way the satellite was realized by 2008 within our own budget. I think we managed the mission. And as we originally planned, this is the mission October 22nd launch of 2008, and gradually keep improving and reaching the moon there. While doing it here, as Dr. Kalam has asked for, not dropping any of the instruments supposed to be taken, plus an additional instrument was brought back here. That is called the 35 kg piggyback system, and that is called Moon Impact Probe. That means this will go up to going to the lunar orbit. The whole thing will go there, and after going over there, that 35 kg probe will be thrown out, and that will be having a small micro thruster that will remove the orbital velocity to the extent of 75 meters per second. Once you have that much velocity removed, no longer it can be in the orbit. It has to keep falling because of gravity of the moon. So that fall is, you can target it where you have to fall, okay? And that accordingly we have targeted. And to the date, this is the furthermost towards south. Nearly 89.9 is the place where we have targeted along with the triangular flag. It is not only a dump mass of 35 kg with a tricolor flag, it also carried 3 instruments there also. One such instrument is a mass spectrometer, another one is imaging camera, another one is an altimeter. So that subsequent mission, when we are going for landing, soft landing is called for. The soft landing calls for an altimeter in a feedback loop to give the system. So that also we carried there. The imaging system until last drop where we have landed, where we crashed, until then we'll tell. The mass spectrometer is the one which will, in case, until then, people thought moon doesn't have atmosphere, until then. Okay, but we carried a instrument, mass spectrometer, that you would have seen here near the airports or railway stations. You would be seeing the carbon dioxide, carbon monoxide thing, no? The mass spectrometer. So similar thing we have carried, a space compact mass spectrometer. That spectrometer will keep flying, keep falling down. We try to see what is the outside atmosphere until 70th. From 100 kilometers and keep falling. Until 70, we didn't see much. But 70 onwards, we started seeing the peaks keep coming. Especially the mass number 18 was keep coming. Mass number 18 means hydrogen as mass number 1, oxygen as mass number 16, 2 hydrogen, 1 oxygen, 18. Okay, that keep pronouns coming there. That means there was an atmosphere getting created during the daytime of the moon. Okay, atmosphere, you don't have an atmosphere, you don't have gravity, less gravity, but the solar rays are keep hitting there, and that will takes out the many atomic numbers keep coming, including water, and the water getting evaporated that comes up. That is being seen in the mass spectrometer. That means this indicates the surface probably may be having a water. Okay, so that further we have gone through the using other instruments. Something called moon mineralogy mapper, supposed to look at the mineral composition of the moon, but it was trying to look at the places where we are supposed to land at there, South Pole is concerned. And you're looking at here, this number blue indicates the IR spectrum point of view, the presence of water. Okay, and here you are seeing the places where they landed, we are not seeing water even today. That confirms, yes, our instrument is working okay, but this tells this is the water presence. And this, we have another instrument, as I told you, host of instruments to go for the Chandrayaan 1 we carried. At that time also many people laughed because this mission carried more instruments to look for water in different technologies. Okay, one is mass spectrometer, another one is IR sensor, another one is X-ray spectrometers. This one is a synthetic aperture radar, which will actively do a remote sensing, look for in the permanently shadowed regions also, trying to see. So there we are able to see in the many craters presence of water and demand of ice for few meters of depth. Okay, that way, the multiple way we are able to see water, not only presence of water, we could produce a water map of the moon. Also we have done that. So in the process, yeah, 2009, the full swing Chandrayaan 2 work was keep going on there. But life is not as simple as that. 2009 up to 29th August, Chandrayaan 1 failed. Okay, Chandrayaan 1, because we optimized so much optimization. That is one of the reasons why it got into an issue there. But anyhow, 1 year it survived. That gives enough data of the moon, the surface, the moon, subsurface, moon, as well as atmosphere is concerned. With that, I think we could get that success. We could do that. But notwithstanding that, the failure of the was a setback for the whole team. Then, as I told, we are working for Chandrayaan-2, and almost 2011, ISRO readied with Chandrayaan-2 orbiter. That we did there. But in this time, Russia was our collaborator to bring the lander is concerned. And they wanted a change. Russia's request to modify Chandrayaan-2 orbiter came another constraint. So the whole team is in the problem because we are almost ready with orbiter. Now somebody is asking for a correction because of the mistakes, whatever they happened to their missions are concerned. So the team is in a really in a big issue. They got desperate what to do with that. But now let us assume, okay, if you are in this position, what would have been your response? Anybody? Any guess? What opportunity? Yeah. Yeah, anything else? Yeah, because the title itself was trying to give you possible answer. The constraint is giving what are the opportunities. Say you look at again the same crossroad, A, B, C. Okay, one is to dump the hardware and look for next. This is what elsewhere people have done. So you would have seen Apollo 17. Apollo 18 also they made a mission, but they didn't do. They dumped it. That is what when you go to Houston, you will see an exhibition. Elsewhere, people have done it. In the space industry, it's not something happened and you cannot carry. You have to wait for that dump. That's one thing. Wait until lander rovers are developed. Because even if he is not given, you can develop for your own compatibility. That's also possible. Another one is find an alternative solution, as you told. But what is the alternative solution? Find an alternative solution. What is the alternative? That is nothing but, you look at here, there is, you may be seeing a dot here. That dot in the space is called Mars. Okay, that means a golden opportunity, alternative solution, alternate target. The same hardware, which is Chandrayaan-2 supposed to go to the moon, is it possible to go to the Mars? There is an opportunity. Is it possible to do that? I think that is the secret of not only less budget, with no budget we have gone to the Mars, to be frank, okay? Yeah. Yes. Yes, I told here, either you can drop the mission or with the Chandrayaan experience, though I told like this, but then when putting forward, this gives problems like this. That means the Mars mission experience by others tells no country or no organization succeeded in first attempt. No country. Okay. But now when we want to go a mission which is originally designed for moon, go to the Mars, your success chances are, you can extrapolate what does it mean. US succeeded only 5th attempt, Russia succeeded only 9th attempt, China was yet to succeed, Japan had to succeed at this attempt. Now you are planning a hardware which you originally planned to go to the moon, now you are putting it to the Mars. So the chances of big question. But similarly, Chandrayaan experience also tells after 9 months satellite failed. Okay, but now here even go to the Mars, your journey time itself 9 months. Okay, so then how you are going to, what is the confidence? So this is the question marks came. But both the question marks, as I told there, are giving an answer for me to success. Able to understand? You're able to understand, no? Yes or no? Yes. That means I told A plus B. A, B I told, no? Now, experience of A tells after 9 months you cannot succeed. Experience of B tells first attempt you cannot succeed. But minus of A, minus of B tells, that means you are able to make A as a minus, B also minus, you can succeed. Correct, no? That means you have the experience, people have failed, 31 times they failed. So you understand properly, you have chances of 31 ways to succeed. One. Second, Chandrayaan-1, why we failed 9 months, we understood. And that is the correction we have done orbiter. That gives an opportunity for us to really test it, go to the Mars, instead of keeping the hardware down. So that means both I can make it minus, make it a plus. I think that's what we have done. And that you look at here, the hardware, not only hardware, the way in which you plan to go to the Mars also almost similar to Chandrayaan-1. Okay, PSLV, same PSLV, the orbiter is put around 22,000 kilometer, 200 kilometer away. So then gradually improve the orbit. Then finally, previously whatever the velocity was given, you give slightly more than that, such that it is captured, it is left from the gravity of the Earth, but captured by the gravity of the Sun. So then almost free of cost. Somebody told the auto charge, not only auto charge, it is more like a walking charge. Okay, it is almost without no fuel, like Earth is going around the Mars, Mars is going around the Sun, this also will go around the Sun. But you should time it properly, you should orient it properly, you should give the thrust properly, such that during 9 months of a journey, when it is departed, Mars was here, it's keep coming here, nearly 26 kilometers per second. After 9 months when you go, you should be just 500 kilometers above the Mars. So your timing, orientation, and the thrust should be pakka, and such that you come over here and do that. And that's what, that means an incremental effort over the Chandrayaan-1, but it's a reasonably calculated one. So that way we went and do that. So though all these things are looking easy, but there is a catch, another constraint. That means with that all the minimum fuel on to do, when you are putting it here, this has to be oriented like this, such that this orientation comes. But when you launch from Sriharikota, orientation will not come like this, orientation will go like that. Go up, not come down. Okay, that means to come down, you have to launch, you have to inject your orbiter, not from Sriharikota, from the west coast of Latin America. Okay, that means how a constraint gives birth to innovation, I am trying to tell that. Okay, that means you need a launch pad near the west coast of Latin America, but your launch pad is in the east coast of India. Okay, but from there only you have to launch. But still you have to go to Mars. Go to the Mars, this geometry will not help. To get that geometry, you have to do that. Okay, innovation came. Innovation is nothing but you launch from here, first 3 stages, then you keep it idle. It is keep on ghosting, the whole satellite is ghosting. When it comes over here, 4th stage, you reinitiate there. That will be delayed reinitiation. You do it, that means from here, as if you are launching from here. Okay? This shows to the people, space enthusiast, a story, but others shows another story. Probably you understand. What does it mean? Okay? That means though you are not launched here, you are launched, you are able to, your capability to launch from here is demonstrating. So that talks about volumes beyond success of mission Mangal. Okay, I think that is the real story. So this is how that happened there. So this is actually told the simulation. Okay, so many simulations we have done to get that geometry. That geometry afterwards we are putting it back, and that goes there. Exactly like Chandrayaan-1. Okay, except the last leg. Yeah, the last leg will be slightly different. Yeah. Now this is the 9-month journey where Mars is coming. Your Earth and our own mission Mangal are keep moving around the Sun. The gravity of the Sun is the one which takes this thing here. That means you play with the nature in a way to be advantageous to us. Yeah. You are keep watching it as, if any small deviation, we will correct it, very, very minute correction. Such that 9 months later, when Prime Minister of India is standing behind us, when Mission Mangal go behind the Mars, and when we acquired, India has become the first ever country to succeed in the first attempt in this is concerned. I think that's what happened there. So now you look back, this is a very, very innovative thing. You look up here, first ever country succeed that way, but you look back, what are all the constraints we had? All those constraints only driven to the innovation. That's what I'm trying to put it here. So, but while doing it, India is considered to be the one of the very, very economically feasible thing. How it has happened? Engineering point of view, look at here. Our schedule was not even 14 months. Mass optimization, we have done there. Small launch vehicle is good enough. Model optimization by heritage. Detailed simulation analysis, that means single model, not typically 4 models they will do. We with the single hardware, we have done that. Judicious reuse of hardware and software. Not only hardware, software has to be that's also called for autonomy point of view. Then test optimization to the heritage and these things. With all these things it costed, when we launched, around the same time, another satellite also launched from US. And we are only just 3 days difference when we reach the Mars. And that satellite was costing $367 million. Okay, whereas our satellite was costing only $25 million. Okay, similarly, less operational cost due to the ground automation is concerned and less manpower cost. So then all put together, integrated schedule management. This is very, very, very important. Very, very important, such that everything comes in line, such that the launch day on that exactly we are launching that way. All the things put together. These are all the reasons how we are able to make it very optimized. That means most economical mission it's happened. Ours is concerned. Yes, that brought me in individual also to the director of the satellite center. Again, on this juncture, you can maintain the status quo, what center is doing, but you can take an initiative. Okay, both can you do that, because but around that time frame, another Prime Minister of India called all the department heads, secretaries to the Vigyan Bhavan, and he thrown open the challenge to them. That means ISRO is able to make in shoestring budget mission to the moon, Mars, other thing. Why can't you specify what you want each department? Let them come out with the satellite, the answers for them, being it agriculture, being it a defense, being a tourism, being aviation, being here, but around that time frame came. Afterwards, you look at here manpower. Say, initially I told Chandrayaan, when it is came, we had an issue of more manpower called for recruitment, all these things. But with the other 2 missions, a lot of inspiration happened there. And afterwards, retention is almost, we are able to retain all the people, including me. I'm supposed to go to jump to somewhere, I stuck with the same ISRO. Similarly, good number of people we are able to attract, because before that, the same around 200, 300 positions, when ISRO asked for the people, not more than 1,500 people used to apply. But after Chandrayaan 1 and Mangal, you look at here, the same 200, 300 positions, more than 150,000 people used to apply. Okay, so that much people we are able to come, and now it is basically for the cream of the people selecting came easier. But notwithstanding that, that manpower after that it's almost stable. Only the people retired, only we are doing that. But now number of missions what supposed to go, the exponentially keep increasing. It calls for another thing. That means what to do. Okay, that means what organization can do, whether it can continue A or outsource B. That means A means you are doing more of an R&D. Now you have to do manufacture, as Prime Minister of India has told, whether you want to do it here, whether you want to forgo this, or is it possible to do both? For that to do both, you have to outsource B. You cannot do things within you. Okay, this calls for another way of doing. That means being in Government of India organization, you should have courage to tell them, yes, we can outsource, even this niche technology. Okay, but for that, you should show the way. Just telling will not help. And that enabled good number of infrastructure being built there, and that's why you look at here. And now the state-of-the-art infrastructure, wherein printed circuit board to fully assembled and tested satellite today rolling out from Bangalore. I think that's infrastructure we made. Simultaneously, 20 satellites can be assembled and can get ready in various forms. So that's how during the time frame, 35 out of satellites you could launch it. That means manufacturing satellites also done. Parallelly, R&D also can be done there. That means R&D and production friendly ecosystem was generated. And that enabled to many things, including, for example, originally Aditya was supposed to be go around 600-kilometer orbit and do the solar chronography. But now, having succeeded Chandrayaan and Chandrayaan 2, the same mission, slightly modified, it gave a courage to us, such that the same mission can be put around the L1 point. I think this redefinition happened during that time frame, such that when you make so many satellites, how you can improve upon your R&D thing also. So that includes many things. That means many places, instead of making a bigger satellite, can you make the smaller satellite? Nano satellites you're trying to make, INS-1A, BC, like that came. Similarly, microsatellites came. Microsatellites also, the SpaceX, I think recently that mission is being flagged off. That also, I think we started working there. Then NISAR is another mission, NASA ISRO Synthetic Aperture Radar, very, very ambitious mission. That also we have identified we can do. We started working with the Chandrayaan 2 hardwares also, almost was ready for launch during that time frame. So R&D also was going on, and making the systems thing also happened there. But as individual, I'm telling you my story now. So as individual, I also got retired by this time frame, August 2018. A farewell from ISRO also came reasonably okay. But now again, the crossroads. What is to be done as a pensioner? Okay, so this has to give some opportunities. What is the opportunity? You can live a pensioner's life in Bangalore very nicely. Okay, pensioner's paradise you can live. Or else you can join the private sector. Or else you can be in the science and technology societal connect, that you can do. But obviously I know that A plus B plus C is the one normally I used to take. So that's what it has gone there, A, B, C. Okay, what does that mean is areas of involvement today, my 67th year when I'm running, this is my area of, the list is probably may continue also, but each one of them also reasonably well we have done that, okay. The drones, I think a farm to border, I think I am a part of that thing in one Chennai firm. And agri waste to wealth is my IIT students, I'm working with that. And that also big factory has come, first ever factory in Maharashtra came in 100 acres, using the waste whatever coming for the banana stem. Okay, it can generate the fiber, banana fiber, and it can generate new organic minerals for the back to the earth. That is coming, such that each banana, today we are cultivating, farmer is cultivating banana stem for the plant for the banana only, but the remaining stem goes waste. Today, the multiplying factor of 25 able to give, that means the banana harvesting, whatever the X money gives, 25 times the stem is going to give. I think that is that means the waste is creating a wealth, then really that is the many thing happen. Similarly, telesurgery and surgical robot. I am in the board of surgical robotic system, wherein we, I think it's 3 years back it started, and now today 55 installations happened across India, including one Aster in Bangalore and Narayana Giridhali also there, and few more are being exported also. And beyond that, we connected telesurgery, and that means from Delhi to Bangalore to some other place, telesurgery in a real form, it has happened there. And similarly, STEM education, something, anything are doing. Space startups also, some of them are advising. And beyond that, I'm writing and speaking on SNT. And one such thing is I'm standing here in front of you. Okay, so this, yes, I write also. Today the date, I think around 9 books are there behind my name. And I'm in the various forums I told, Tamil Nadu State Council, SNT2, Tamil Nadu Aerospace Committee, in various forums. I'm trying to contribute to my time and spending my time reasonably well. While doing it, I think recently I also had a nearly 1.5 month visit to US. Not only here, even other places. I think UN, I had an opportunity to work for 3 years as the chairman of the working group of the whole. And where I advocated when the next International Space Station has to be formed. Today, India is not a part of the International Space Station, that's getting old. But India has done almost everything except International Space Station. That means Earth observing spacecrafts, almost everything we have done. Moon we have gone, Mars we have done, our presence we felt there. But International Space Station, now existing thing, it's getting outdated, and a new one has to be identified. For that, there is a very, very active deliberations to bring India also into the loop, and India also planning to make its own thing. But somehow I'm advocating, instead of doing this around the earth, because whatever you do, maintenance cost also more. And over and above its life is over, it's creating a problem there. In spite of that, why can't we make once for all at the moon? southern space of the moon is concerned. That will not only to give you maintenance is free of almost free of cost, and it can give some resources back to Earth also. Okay, so that way I advocate more towards that, and I think this is getting momentum. It is getting momentum. There is a possibility many countries, including India and China, also working together. I foresee that can happen, and towards that I am advocating many things, and that can help even beyond go to that also. So that means beyond the Earth. I think I used to tell repeatedly this sentence, and that means you look at here, US itself we told this. America is a land where the Columbus was trying to find a route to India. Correct, na? Erroneously, he went and identified a place that subsequently America Vespucci discovered, and that has become America. That has become a land of imagination and inspirations for the youngsters and this generation. But that America failed to discover water on the moon. There, India discovered water on the moon. So I feel the next America is nothing but the moon. For that, India has definitely good soul, because America and India, some connection is there. This connection, moon, it can get much better way. So one is in the way of collaboration, another in the way of next humanity, and connecting, and beyond all these things, trying to show the scientific community how we can work together in a better way. Okay, and that we are able to show it's a good thing. I think it's something like that I am advocating that. While doing all these things, yes, what is back to our own people? Okay, you look at this. This is another thing I'm trying to put the next level of entrepreneurs across the globe, and as well as within India also. Yeah, just another 5 minutes I will take. Wherein I put my observation. That means you look at here, I'm not going much beyond Indian space program. In space commerce is concerned. 2014 to 2023, this time frame will work out here. 3% of the launches worldwide, whatever happened, has happened because of PSLV, GSA, whatever it is. So that got grown 9%, 11%, peaked 35%. 35% we have beaten even US. Okay, that is the situation came in that time frame. Both our own satellites and the satellites meant for somebody else, all put together, that many launches took place. But what happened is afterwards, looking at all these things, as I told, I was there in the 3 years, the UN forum. So we provided an opportunity. India is now ready to handhold the nations who are not spacefaring. Okay, and so the countries were brought every year and given that orientation back in India, what India has done and what India's capability, and giving some sort of hands-on experience to the people there, such that when they go back, they will be able to advocate their respective countries to becoming a spacefaring. So that way, some sort of virgin market we are trying to create. That's also happened. So now you look at the other way, same 2014 onwards, the number of satellites being launched across world. Initially I told what is the percentage of launch India has done, and this is the total number of satellites being launched over the years. Now up to here, then it has gone very exponential increase happened. Okay, now we not only we are talking about a few hundreds, 200, 300 number has become as 2,000, 3,000 per year. Okay, and why that is happening is the reason being like this. That means all connected world being object is being done there. That means today cell phone able to connect you and me wherever the cell phone tower is there. Okay, but there are good number of places cell phone tower is not existing. Whereas the small satellites constellation can give you connection that way. So that way 7 billion people, 30 billion devices, 50 billion machines, all connected. That means everyone to everyone connected, everyone to everything connected, everything to everything connected, everywhere to everywhere connected. That means every many things are coming. So that calls for good number of satellites to be launched, and they have launched also. Okay, and while they did like that, what happened to our contribution? Our contribution has fallen because the number has gone, and that many percentages point of view we have fallen there. Okay, this is an observation. But this observation gives another opportunity window, whatever I told there. Na? Similarly, I foresee an opportunity window from this. Here, what is happening is, and so many thousands of satellites were launched year on year. With that, the constellation has been made, but now they have to maintain that constellation. While maintaining the constellation, you don't need launch to thousands. Okay. Now what is happening when we did like this, how our number as percentage increased is we shown to the world single launch vehicle, multiple satellites we launch. We only showed the world. They have taken it and they have done this and they have made our percentage less. Correct, no? But now you hit back other way. I am looking this an opportunity. Now onwards, these launches will not be few hundred, but one launch, few hundred need not launch. So many satellites will be launched. So 6-7 years from now, one satellite or other, daily it may lose its life. Okay. Now you have to put back the satellites. That is not in big numbers, 1 or 2 daily. That means there is an opportunity to launch 1 or 2 launch vehicle daily. Are we ready for that? Okay. If you are ready, we can get back this. Just I am telling, because this is the people who are known in moment startups, other things are there. And I see there is an opportunity. This is called on-demand launch. One satellite is lost its life. I want to launch today. Are you ready for that? If you are ready for that, you have a market. Okay, this is what I am trying to show that. And towards that, I think some activities also I am trying to show that. You look at here, USA, I think yes on May 22. Now I think it has gone up also. USA got this many satellites, China, UK, that way, India is standing here only. But I put a star in under UK. In that, 486, 475 belongs to Airtel, for the Airtel. It is registered there. Okay, so I feel that it can come here. So that way, we are coming to that place. You got the point, no? That just means what? The lesson learned is means what? Future of Indian space program is not ISRO alone. ISRO plus Indian private industries. This is already happened there. Okay. Now, when that happens, towards that definitely reorganizations already happened there. So that means the system is getting evolved. Now, beyond that, among so many launch stations, one more also coming at Kulasekarapatinam. That gives an added advantage because even the small satellite launch vehicle can put up better satellites there. So that means now you look at here, a growing number of small satellites within India is happening, small satellite launch vehicles. This all put together, now you are able to create a real ecosystem around here, a cost-effective ecosystem, that will enable ready-to-meet challenge, rapid action ecosystem, high-frequency launch on demand. This has a loaded value. Rapid action ecosystem is a dual use. And high-frequency launch on demand is a commercial use. Both is possible to do that. That very, very opportunity window. I foresee it is sitting here. And towards that, already governments are taking thing. Both state and central government is competing to make this to happen. And towards that, now you look at here, government of Tamil Nadu has come with the draft Tamil Nadu space industrial policy. First ever time, a state government has come because central government has given to the private industry. Then I advocated to the state government. Their privatizing doesn't mean state government cannot do the function. Okay, now state government will do the 50% of creating ecosystem, such that private industries will encourage to make what you look for. Okay, such that they should be ready for A to Z to the launch of multiple satellites day on day out. I think that is day is not for. I think yesterday I would have seen that Elon Musk selling already 6,000 satellites there in this place. Now he wants to make it another 30,000. Huge numbers. Okay, but when that is okay for constellation is concerned, but maintenance is concerned, you don't need that many numbers, and for that you need this. So actually, this is one of my mission now. Feedback on draft, because this policies is a part of that, but to make the entrepreneurs also a part of this thing, we are looking for feedback on draft Tamil Nadu space industrial policy. I think this is one of the things when I'm going around. Probably I'm also putting forward here. How effectively you can make use. The government is trying to give near the launch pad all the ecosystem to generate around 2,000 acres have been earmarked, and you can connect and work like that. Ecosystem is coming out, how you can make use of that, probably you can think about that. So with that, thank you very much for giving that. Now, basically what I'm trying to lay is constraints give opportunities to make innovation. And now the opportunities are waiting for innovation. There's a big difference. Okay. Now many things are made and get ready. And how we are going to use this effectively so that we are really economically viable solutions we can give the space. I think it's very much is sitting there. So it's all up to us how to we make use of this. Thank you. Yeah.
So on the same lines, I want to understand how do you see the evolution of satellite communication for general public. So as you also referring that like n number of people, billions of devices connected. So we have the technology, but what is that constraint that is putting for general public to not to use?
No, it's only a matter of time. Now you look at here, both to the best of my knowledge, both SpaceX and as well as OneWeb of Airtel is competing to get the policy, and technically they are ready. One of them going to win. My best guess is OneWeb is going to win for India.
Would it be like something by next year or something that we can?
Yeah. Because what is happening is this is dual use also. Okay. Because now you know Ukraine war what it tells.
Right.
Ukraine war is partly fought with the SpaceX also. Correct, no? Similar thing. We cannot be blind from that. So with that, my bet is with OneWeb.
Okay. So rather than technical,
that will happen. So once it's only policy. Otherwise, I told na, I already technically we used for telesurgery using the OneWeb. Already we have done. It is anywhere to anywhere connectivity is already existing. It's only a matter of clearing. I think my feeling is it will happen.
Thank you, sir.
So on this, on the launch or demand, what you talk about, like it's a very important thing.
Yeah.
Right now, where are we on the point of launch or demand? Starting by giving you a requirement today to the ecosystem. In what time frame are we able to launch or will we be ready to launch?
Okay, there are two aspects. Actually, when I was there itself, I was trying to talk about the people. Two ways we are trying to about that. One is make everything available, be in a space, and you come down when you want. That is anytime you can do it. It is there with us. It's almost there with us. Another thing is now you know that is the reason a good number of launch vehicles already getting ready. Even SSLV by ISRO also 3 launches have taken place, which gives only 24 hours countdown compared to any other thing. So within the 24-hour notice, theoretically it's possible to do that, provided you create an ecosystem such that all the things are ready. Okay, and pick and place and launch. Theoretically it's possible. I think for that people have to work together. That's what I'm saying. Work together such that all the stages be ready. Okay, and tomorrow you have to launch. You tell today, it can be done.
While it's understood absolutely that will be possible in a later time frame.
Exactly. Yeah.
Today, where are we?
No, today is concerned. As I'm telling, SSLV is technically ready, and it is now handed over to the private industries, and the private industries are making that ecosystem around Kulasagirapatnam. Because in the Kulasagirapatnam, when you make that the same launch vehicle, 2-3 launch satellites also we can launch. Whereas in the Sriharikota, you have taken a roundabout path. That good amount of fuel we are spending there. So Kulasagirapatnam is theoretically it's now ready. Okay, because this then other 2 people also, even the mobile launchers good enough for them to do. They're not an elaborate launch stand is called for. And towards that, I think SSLV technology transfer is already in the place. As far as I am concerned, maybe within near we should be in a place, in a position to what we target.
So we follow up with that. We require for defense purposes a lot of different sort of satellites, which might not be possible for this private players to actually work on. And so are we developing the defense ecosystem also along with this for ensuring that launch on demand, which might be more required for defense? So is there a possibility?
No, I think at this point of time, discounting private players may not be prudent. Oh, yeah, yeah. No, not discounting means you don't eliminate, I'm telling. Yeah, 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 yeah.
Is there a collaborative ecosystem which is being planned? Because defense would require a specific set of things, slightly different.
I agree, I agree. Yeah, yeah. Basically, what we should do is only that portion alone to be tweeted. That portion alone to be tweeted. That is strategically you should do that, such that the major hardware comes from the common. Exactly. Yeah, 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 yeah.
Good morning, sir. Sir, this side. So my question is about your proposal of state industrial space policy. Government of India has created InSpace, which is a single window organization for all activities because space is a state subject.
Correct.
Now, you proposing for a individual state policy, is it not in dichotomy to the national objective and also the legal connotations of it?
No, not like that. Basically, what I'm telling is, union government has told it can be privatized, but now what I'm telling is, state government to create an ecosystem to enable the private industry to do better. No, but InSpace, no, to the best of my knowledge, InSpace and state already working together. InSpace and state already working together to create common facilities such that, for example, vibration test facility, EMC test facility, thermal facilities, private industries need not individually need not build. Okay, but you identify near that space park and you do it. State government gives a place. InSpace also gives some whatever that around 1,000 crore, whatever the money comes, it's going there. So the infrastructure is built for the private industry to make use. See, it's state government's thing is to enable ecosystem in a better way, halfway through.
Because I foresee that maybe suppose 10 more states come out with these policies,
Mm-hmm.
then there may be issue in command.
No, not like this is basically to build the system. Command and control is a total different thing. So what we are telling is, whatever said and done, you have only very few launch spaces. Okay, what I am telling is, around the launch phase, you build up the ecosystem that will be more economical, that will serve you on demand. Tomorrow I want to do, you can be ready by today. You take it from elsewhere to the launch phase, that even that logistic is an issue. You got the point, no? So the idea is, near the launch pad, you build up the ecosystem such that you need not go back and forth. Say, lessons learned helped us Mission Mangal. We also learned a good number of lessons from keeping a Sriharikota as a launch pad, and many things are coming from across India and reaching there. There are instances where we have a satellite was moving from here and it got into a problem. And even the movement itself takes 2 days. But now you need a launch every day. 24 hours not you have to launch, but your transportation itself is minimum Trivandrum has to come in, 3-4 days it takes. Okay, so you have to generate the thing there. But now you cannot ask private industry come and do it there. For that, halfway through, government has to help. You got the point. It's only the government to help the ecosystem to generate there.
Sir, here.
Yeah.
Hi, Shreyans here. So you've talked about making space industry accessible to private players. Now, at the end of the day, you're still constrained by cost per kg of LEO launch.
Yeah.
And that is a major constraint. Even if you look at SSLV or any other system that is available in India, you're at the very best looking at $4,000 per kg. That is still very expensive for a lot of players. Now, do we envision to bring that cost down by launching every single day? Or how do we bring that launch down? Because as soon as you bring that launch down, your satellite production is not that expensive. It's how you get up there and the cost that you're getting up there with. So what do you think can happen in this kind of space?
Now what is happening is the game will change when you are launching, for example, you have the Falcon launch, heavy lift launch is there. There you launch 7 ton, 8 tons of few hundred satellites together. So their weight-wise launch cost, then per kg will come down. No, you got my point, no?
Yeah.
But tomorrow, this is not the requirement. But why I'm telling is, in a train when you go, you are sharing the cost with that.
Exactly.
But when you are going in even auto, it's your own
Yeah.
thing. Oh, you got the point, no? So that means there is a demand. Tomorrow I have to launch. Time also comes into picture.
Exactly.
In that time, in that orbit, when you are ready to put, the marginal cost has to be paid.
I understand that,
Yeah,
but
yeah, yeah.
I can make a
You
big
got the
satellite.
point, no?
Yes, yes, yes.
Per kg, you cannot compare that per kg, but this per kg you
Yes,
cannot
yes,
compare.
yes. I mean, it's development cost per the cost of launch. But what I'm trying to say is, I can make a big satellite, which is 100 kgs,
Oh, yeah,
and that can be very economical for the likes of ISRO or
Correct. Yeah,
Agnikul or Skyroot,
Correct,
because it's a big package satellite.
Correct, correct,
Now, once I move to smaller satellites, each one is going to cost a lot more to each particular customer. Then it doesn't become economically feasible for these customers to approach this space.
Correct.
If we want private players to access this space, we want to make this price cost of small satellite a more democratized for them. How can we do that as a space industry in India?
No, that is what I'm trying to see. The whole system, ecosystem, you try to bring it there. The overall the logistic point of view, overall the waiting time point of view, overall, for example, as simple as minimum quantity procurement. In the procurement point of view, instead of buying a procurement, what you have done for the one satellite, when you buy for 10 satellites, when you for 100 satellites, costs are totally different.
I-
You got the
Yes,
point. No?
yes.
So now what we are telling is we are trying to create an ecosystem such will enable that to happen.
But what if I can't afford 100 satellites?
No. You need not afford 200 satellites. But there are 10 people, each one afford to have 10 satellites. If you make an ecosystem, that is possible. It's okay now.
Okay.
Ecosystem is not for the one individual. Ecosystem is meant for the holistic approach, such that even the single hardware price you can bring down.
Okay.
So somebody making as simple as a DC-DC converter, today he makes per satellite five numbers. I'm telling instead of 5 satellites, you have 100 satellites lined up next to this many months. You make 500 number. Definitely cost per unit will come down.
Yeah.
Similarly, we are talking about the launch vehicle. Also, when we are keep stages from DC-DC converter to all the way to launch stages, the numbers will keep changing. Similarly, your geographic location of Klesairapattinam gives another advantage of this. Beyond this, I'm telling, state government also should give, because you are giving a highly skilled people to work in your place.
Yeah.
They also have to give. So this is what I'm trying to tell. Ecosystem is many people try to give, such that you have affordability of the system happens, and once this happens, it will sustain. Commercially, once you start and this happen, then things will keep sustaining, because then I expect even a day will be there. Even for the Elon Musk, his some 5 satellites to be replaced, to be done in a faster way. He approaching Klesairapattinam is not far.
Yeah.
You got the point now? So that means 35,000 satellites may be there. All 35 satellites need not be maintenance point of view. Daily 1 or 2 as to go, requirement will come. Today he doesn't have a satellite. Today he doesn't have a place as good as Klesairapattinam. Today he doesn't have manpower as less as what Indian engineers are there. All put together is sitting in India.
Yeah.
And you make that ecosystem that affordable. Okay, so then I feel that's possible.
Okay.
It's only you have to, the vicious circle you have to generate. You have to generate.
So we would take another 2 to 3 questions only now, and then we can continue the discussion during tea break.
Thank you, ma'am. Sir, my interest is on space weather, and I read in one of the launch manifest of PSLV that T-4 hours you will get an initiation data about what is the current solar flare activity. Sir, where does this data come from, sir? Does it come from National Physics Laboratory, New Delhi, or URO Center, sir?
No, basically this is even locally also balloons being launched.
Okay,
Okay, and NARL is a part of that system.
okay,
NARL scientists also part of that system. So that is not a really space weather, it's only atmospheric conditions. Space weather we will get a priori.
Very early.
Very early. Space weather is concerned, it can be early. Even today, Aditya alone also is a part of that thing is concerned. That will come early. But we are
what if
talking
it is
about the local atmospheric thing. For example, when you are launching, we should something called wind biasing. We are supposed to give.
Okay.
When the altitude goes, how the wind comes, accordingly the biasing has to be done for the trajectory to do that.
Correct.
That for that point of view, you should be as close as possible. Some few I think half an hour, 1 hour before, whatever that balloon even also sent there, and even the ground radars also look at the atmospheric conditions. So that way, the altitudinal profile of the wind velocity is coming there. So for that only this is coming. This is only local weather, not space weather.
What if it is there an X-class flare that is happening in the last 16 hours timeline? So will you be postponing the launch based on that sequence, or?
Okay, that you look at there, that's predominantly happening for this space.
Yes,
If it is a higher thing, definitely we have to do that. But today, this sort of a flares point of view, we are taking precautions for the operational satellites to maintain.
Okay.
You got
So
the
you will
point,
put it on safe
Yeah,
mode?
yes, that is the operational satellites.
Thank you, sir.
Sir, thanks for sharing your whole journey with us and in other common platform. And my question is slightly different because of time constraint. I put it to one final question. The kids and the generation below us, there is nothing other than mobile or the common media platform that they get educated about this thing. So can there be a suggestion, being you being in such place where something related to space to be taught in the class in a much as a subject where the interest is developed to go forward, not just when you get into a professional course. This is where the next generation will shape up and be more informed. ISRO does many of the free courses, but you also know that it doesn't get public. I mean, it's only through WhatsApp link and things people get to know there are free courses to do. But to generate that thrust in the kids, something to be proposed in government syllabus. Considering the background that you have come, sir, from a very
I agree.
struggling bagrund.
I agree. I agree. What you are telling is I agree. That's why one of them I told the STEM education where I am trying to participate. So wherein today, I think in couple of ways we have done in a seeded way, and that has for example, I am a part of an American India Foundation, wherein their CSR funds I can take it and take it to the education point of view. And that way, even the school where I studied, today is not the school where I studied, it's not the same way. It is one of the best, I can tell you, in Tamil Nadu, one of the best, government school only. And taking that model, Government of Tamil Nadu this year has allotted 500 crore budget to that means that calls for a school, a STEM education, the 3 classroom to be model we have done that way. One, from Ohm's law to full rocketry building, students can do. And we have done that. So, but while doing these things, we have to train the teachers also. The teachers also we have given some sort of a assignment to the student thing. The best out of that will be selected. That means each subject, light or sound, whatever it is there, they can read it, whatever it is there. But they should not take more than 8 minutes to tell what their subject is to the students. That video thing they will able to generate and do that. So then the third thing is we also provide BA graduates who are enthusiastic this way, passionate to that. They will be the trainer, connecting trainers, these people and these people, and such that our idea is today India is able to create the grandmasters in chess, the school students. They are school students. We are able to generate good sportsmen, singers from the school. Why not generate scientists from the school? Exactly. I think that is the motive we have done that. And that school is now being replicated within Tamil Nadu by state government's 500 crore budget this year has come. I hope, I think we have recently discussed with the Orissa government also. Something may happen there. Gujarat also is inviting that. I think this momentum will happen, such that our idea is recently we launched a second rocket with the hybrid rocket, first ever rocket done by, in India, done by school students. And they launched in Mahabalipuram in a mobile launch pad. And this we are replicating. In that, around 50 Dubai students also joined. Now I am trying to take this to latest my US visit. I used that also. That means future of the world. Future of the world. I'm not telling India or US. Future of the world is a collaboration between India and US. Moon, Mars, much beyond. And when that is happening, Indians born and educated here, Indians born and educated in America, they need to collaborate. But culturally also to come there. For that, I feel the space education is the one thing possible. So we are mooting a thing that will enable the selected students from various schools will come to a level, 100 will come from the national level, 100 from the national level from there, and they work together in a NASA or ISRO laboratory, such that tomorrow's scientists are getting generated today. I think that's the thing. Year on year we are planning. I think this will happen. This is actually my ambitious goal is much beyond Moon and Mars. Is bringing those people, taking them to that level of exactly.
So, morning, sir. Thank you for your great insight, sir, on innovation. Sir, my question is that you have advocated the concept of more launches, a launch on demand concept to replace the aging satellites. Like we at the Indian Air Force are working with industry to create something called a fuel station in space, wherein the aging satellites life can be extended and which might reduce the launches. So which one would you see as a more practical solution in the future going forward? And what would be your suggestion for the industries if they are going for a concept of depending upon the fuel station in space?
It's both are there. Both are required. For example, today's SpaceX, whatever the launch is going to take place in the coming weeks, is nothing but the two satellites coming together and docking. This is a prelude for the possibility of extending the life of the fuel or replacing some power module. That will happen there. So it is like you like it, your humanity itself. Okay, the longevity of the people has increased. Right now, longevity of the people. Once upon a time, the age was 40, 50, 50, now 70, 80, like that. So that we have taken care. Same thing for satellites also we may take care. But notwithstanding that, you need birth ratio also you have to maintain. Correct, no? Because what is happening is you keep on extending the life of a person. One day or other, he is not relevant to the world. It will happen, no? It will happen, correct, no? Okay, whatever I talk, my relevance will slowly go. But the new generation is required in human. Same thing in satellite. Okay, your cell phone. When did you buy your cell phone? Huh? Oh, you are a exception then. Every year people are changing because it's getting obsolete. Okay, even every year is not there. After 5 years back, then you have to look what is the cell phone you are using. Okay, because this is satellites will get obsolete. Okay, 10 years, 15 years back, once upon a time, yes, you are looking for the satellites life 15 years. But 15 years before whatever you have done, that may not be relevant tomorrow. That is the thing. For example, as I told, initial satellites, what we told, that time it is the best when you are bringing the cable TV. Cable TV calls for a big dish. But now today we are not having a big dish. Now every house is having DTH. So that satellite has no relevance for that. You need another. But now tomorrow satellite is not even the dish. On move you should have a television. Correct, no? So that the satellite cannot provide that. So extending the life for the satellite is a question mark. You got the point now? See, extending the life for everyone is a question mark. You need both.
You
need
good
both.
morning. Good morning, sir. Hi. I'm really interested in the applications of satellites for industry, particularly in regards to communications, because it seems to me that as India becomes more important globally, one of the markets we can capture around the world is communications, satellite to Earth and all those other things, and transferring data. But one of the threats, like we see with China, is security. So I'm interested to know how ISRO wants to exploit new like really cutting edge technologies like quantum, which are just coming into picture now to secure communications, and how Indian government and private sector sees these things?
Now, already a good amount of work is going on there. The initial success has happened, and this is the field wherein space as well as the other scientific laboratories working together. For example, Raman Research Institute and ISRO are working together, and such that this cutting edge technology also for the safe and secured communications, that possibility also exists. That's already work is going on.
And the only reason that they are able to, make so many launches is because they have the reusable rockets and it is more profitable for them. So, like in your vision, how are you seeing ISRO compete or India compete with SpaceX and other space agencies who are also trying to do the same thing?
No, what I am trying to show is one is geographically better position of a new launch pad, and the new set of small launch vehicles, and then this along with an ecosystem which will which would enable the production of the systems, either the launch vehicle or the satellite or the launch or the operation, the more economical. So it is making use of the place and making use of the small launch vehicles, that will have a turnaround time of within 24 hours you must be able to launch, and towards that you must be able to make off the shelf everything available. Okay, this when you make this ecosystem, because it's not only the money, somebody will look for time also. You got the point, no? Say when somebody is looking for the time, today you look at there, I want to take, my son is sitting in Electronic City, I am sitting with DR Nebura. Something I have to send to him, time is more important. So porter, I will be spent 200 rupees I am spending. Okay, but it's okay even after 1 week if it goes, so if 50 rupees I can send. So that is the thing. So wherever my feeling is, when the constellation maintenance is concerned, time is going to be a prime. That is one aspect. For that, we can be equipped with that in a better way, wherein the satellites, because the reusable launch vehicle and things like that will work it out only for the bigger launches. Smaller launches may not work it out in that way. Smaller launch, I think best thing is the place can give a better thing, and you create an ecosystem that will make the whole thing less.
Also, the initiative taken in more being able to facilitate more launches in space for, like, for example, ISRO collaboration with more private players, right? But the question I want to ask is that it is possible that many of the launches are having common payloads, right, and have common objectives. So in order to further reduce cost, right, are there any initiatives being taken so that the data, after of course taking care of all the privacy concerns, be shared for the people so that the additional cost of, say, launching can be reduced and the people can directly work on the remote sense data?
Yeah, remote sensing point of view, yes, remote sensing point of view, I think already look at here, our Bhuvan portal, that type of thing is giving an opportunity for the data sharing only. Yeah, that model being there, what I'm saying is that model being there. Now, when we keep improving upon the temporal and spatial resolutions, okay, and spectral resolutions keep improving, then how to do that? There is a mechanism already there. Okay, how to add to that, and that is only policymakers have to arrive at that. Yeah. No, but now what is happening is now even for remote sensing, private players also started moving. So like communication remote sensing policy also is coming out, and this will happen. But the only thing is this is a dual use. Okay, because some of the places you have to mark it and do that, and you cannot allow the things to happen. So that way, there are some nitty-gritties we policymakers have to see to that.
Like one of the key concerns, then there can be two that can be just come to one person's mind. One is that one question is isn't like one cost benefit could be given to private players so that they also share their data.
Yeah.
The concern
Correct,
say,
exactly. Yeah, yeah.
some privacy concerns.
Exactly, exactly.
Those things can be taken care of, right? So,
Exactly, but that don't, policy is that how to take care of that.
I mean, even in IISc,
Yeah,
like,
yeah.
for example, I was student, research student, I had also worked on, not at satellite level, but at a drone level.
Correct, correct, yeah, yeah.
As an email limiting, how to make certain parts take a quick. So you have a large corpus of research students or even people who are enthusiastic about.
Correct, correct, yeah, yeah, yeah.
So how can they come on board and help with these issues? As a student or as a research enthusiast? So any things that are
Now, what you're telling, that's what Bhuvan portal you may be aware that already provision is there, but now how to add this resolution. That is the, so now as per the policy, there is up to some resolutions being allowed. Okay, beyond that it is not given, and up to some time is allowed, but not almost not real time. Yesterday's data may not be available to you. So both time wise and resolution wise, there are some restrictions as today. But this I think will keep moving forward, because the same thing happened when the cell phone came. Correct, no? Originally, even the phone itself was a thing, then cell phone, now satellite phone is going to come. Satellite phone has a restriction today, but that will evolve. So it's a matter of time, it will come, but people have to see to that how this dual use issues, how it can be addressed. That is the main thing people are looking for. I think probably it may come for the remote sensing policy draft may come. So like whatever I told for this draft policy, they are looking for the feedback. Similarly, for the communication policy was there, and it was put forward to the people, and that was absorbed. Similarly, remote sensing also is going to come. Remote sensing also will come.
Yes, sir. One question.
Yeah, yeah.
So is it offsetting from million cost or something like that? How it is a bigger cost?
No. What is happening is satellite per se. No, satellite, basically that is a huge satellite, huge structure. Okay, to maintain it around 400-kilometer orbit, you have to spend for the satellite alone good amount of fuel, and refurbishments have to keep moving. Change of battery, change of fuel refueling. That you are keep doing it day in day out. That's called for. Okay, even if the people are not going or not coming, the supplies have to keep moving to the ISS. You got. If you don't do it, it will fall. That's what happening now. What is happening is there also like even ISS itself, we are not keeping it for lifelong. After 15-20 years, it's becoming obsolete. People are next generation are not ready to go, because they want spacious. They want its own advantage. So that is being allowed to fall. But in the moon, that thing is not there. Moon is there, no? Moon is maintained. But anyhow, going and coming, and the people are having some problem to attend to them. So that space station also there, they are also there. But here and there, not much of a difference. When you go and dock this and do versus moon is concerned, time-wise not much difference. But maintaining, that means moon is not going to fall. Space station, if you don't maintain, it will fall. I'm telling about that maintenance. Fuel maintenance.
Sir, one last question, right? So, first of all, thank you for the presentation and your contributions, sir. And we are truly inspired by you. My question, I was planning to ask something else, but just for constraint, I'll ask a different question on your leadership style, right? So, we or at least me, I struggle to inspire 20 engineers, right? But you are inspiring 20,000 engineers and for rocket science, right? So, how do you do it, and are there any pointers that you would like to share?
No, I don't think so. It's anything intentional. to inspire somebody. No.
Requires balancing and maintaining and working with the constraints as well as
restraints.
Yeah.
Whether it is about the leadership, morale, or momentum, or tasking, there will be many times when you are really समझ क्यों नहीं रहा है? Basic question. यार मैं बताने की कोशिश कर रहा हूँ ये कर क्यों नहीं रहा है? या जैसे as he said, यार I am so passionate यार रात के 2 बज गए हैं and तेरे को पता 2 बार दुखाना पड़ रहा है, So if that be the thing, sir, what will be restrained and as he said, what are these touch points which you would like every one of us to involve and engage in?
Yeah, I think, as I told, it's not intentional, but my main thing, if you look back, what would have happened like that, is basically when I was seen, when I suggested something, I was with the beard. When I suggested, he didn't neglect me. He didn't throw my suggestion. Okay, he took it correctly, and he allowed me to grow. And that is only spiral. He initiated the spiral. So I learned from him. Okay. There are two things. One is your passion and patient. You should be patient enough with that passion. No, I think it's as simple as that. Because your time nobody can take. What you deserve nobody can take. Only time, there may be time will be there, but you should be patient enough to be that. That's it. Okay. Thank you.
Hello. Thank you so much, sir, for that wonderful lecture. And this will be a memorable lecture for us forever, I think, all of us. Thank you so much.
Thank you.